Yo, 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 what's up, everybody? Welcome back. Today, we are working on generating an interactive map of our code base for the purpose of trying to help gather context. When people are watching me code, I might be working in a semi large code base, right? And in a given stream, I will be working on some subset of that code base, right? Now, we need some way to visually give people a quick overview of what we're working on today. We give some context, right? We put in the stream, we put on the right side, like, hey, we're working on text boxes today, right? But when we're working on text boxes and we're jumping around the code base, it's kind of hard to follow what is happening, right? So, what would be nice is if we could, on the right side of the screen, show some form of like visualization of the world we are working in, right? So, in the image editor, we have like main, and main, he talks to like an application, right? And the application talks to like a renderer, and the renderer talks to like object storage, right? And app also talks to object storage, and renderer also talks to like shader storage, right? Which is also talked to by app. And then like kind of like GUIs over here, and GUI references app, and he references shader, and he references object, right? This tree gets kind of out of control, but it would be nice to be able to draw this tree and then cut out pieces that aren't relevant for today, right? So if we're working on like just like text box stuff, we'll be like, okay, well, we're mostly kind of in like the GUI area, GUI, right? And the GUI kind of talks to like text box, and both of these guys talk to like the widget API, right? And like when we're working on text boxes, we might kind of be looking at like text rendering and like maybe seeing like something that's kind of more analogous to this amount of information on the right side might be useful. Maybe these things have some like flavor text associated with them, right? We can say like, okay, we've been spending a lot of time today on text box, widget, and GUI, and maybe we can like put one sentence explanations of like what those things are. So like we could write in widget like this is our like general widget abstraction, kind of like an interface in other languages. Text renderer's job is to render text and lay them out, and like I don't know. The idea is just like try to give some form of overview. Now, we will experiment with what the best way to represent this is. I think having it be some form of fun visualization where maybe the current file that we are working on gets like a little like maybe we draw these things as a constellation of stars, right? And whatever file we're working on gets like a little rocket ship. And the rocket ship is like orbiting around whatever star we're working on. And as we like navigate through files, he kind of flies over to the relevant spot. This is kind of like what I'm thinking. That's kind of what I'm thinking. We will have to play around with visualizations to see what works and what doesn't work, but we know that we want to model connections between things as well as hierarchy between things, right? That's for sure what we know we want to accomplish. And so we've been working on this code map. A little bit like Gorse. I don't know what that is, but maybe. So this thing, right now we have a application that can launch a language server. Um, let's see. I made a couple changes, but he should be able to launch a language server and query references about a certain thing. So if I run like code map, hello, zig build, zig out bin code map, maybe. We need. I've modified this a little bit since yesterday, so hold on. Let's just make our little config. Our config says here are our language server parameters. So I think we have like project root in here. Of home streamer work svimp. Oops, oopsies. Oh god. Home streamer work svimp. Say we want to work on our image editor. Hold on. I wish I had done this a second ago. I kind of forgot I did this, but our config needs us to write down the language server arguments and the language ID. Okay, so the language server is just ZLS, and the language ID is Zig. We're trying to abstract away the idea of like language specific code in this thing, so that's kind of why it's like this. Okay, so when we run this thing now, we pass in config.json, we pass in the file we want to look at. So say we want to look at svimage editor source main, and we want to find references to something at line 19, column 7. Fuck me. We need a comma here. Here, okay. So this is him listing references to those files. So that's where we are right now. We have a way to query a language server, which is like when you open your editor and you ask to go to definition, right? That's probably using a language server under the hood. We ask the language server, hey, you know stuff about the code base. Could you tell us who calls this function? Which is step one. We can now draw a line between two things if we know where they are. But right now we have no idea of like where functions exist in the file. So I think we want to walk the project, list every function in the project, query the language server to find references between those things, write them down, and then once we have that data, we can start playing with visualizations. So the plan for today is to start building that database. So I believe we can use the idea of, in a language server, if I go into here and I type, I think it's vim lsp buff. There's like something, there's a way for me to like ask for document symbols. Vim list document symbols neovim. I believe that this will kind of give us what we want. I know that there's a way to do it. LSP. Oh, here. Document symbol. Where was that? Document symbol. Vim LSP buff. Document symbol. If I type this, this gives us a list of all of the symbols in our file. And so we should be able to ask for this to just tell us where all of the functions are, maybe as well as where like types are or constants or something like that. We might have to do a little bit of trickery because in Zig types are values. So if we want to find types, we might have to get a little creative. But we should be able to ask the language server to list the stuff in our file, and then maybe we can like query things about that stuff. Hand wavy. And then once we do that, then we can ask for it to give us references for everything, and then we'll figure it out from there. So I think the plan is ask the language server to tell us where all of the stuff that we might care about is, ask the language server for who cares about that stuff, build a database of references between things. That's it. We'll see where we get. I don't think LSP can, but Tree Sitter could. I think that the language server can get me at least. Yeah, we might need hierarchy. And so Tree Sitter was in my back pocket for that. I guess we will see as we go what feels like it makes sense and what doesn't. Because you're right that we do want to keep hierarchy as well. Let's just start and figure it out. Because we've been talking too much. Let's do some typing. Okay. Actually, yeah, I think you're right. That, okay, so within a file, GUI, we are going to have widget, and widget is going to have like render, right? There's kind of like some hierarchy to this, and if somebody calls render from somewhere else, main, if he calls render, we want that to count as a reference to render, widget, and GUI, right? We want all of those things to count because a reference to a thing in GUI is a reference to GUI as well. So that means that we need to preserve hierarchy, and I don't know if the language server can do that. So can we look at language server spec? Let's just see what comes out of the document symbols thing. And if that looks like it can give us hierarchy, that's great. But if not, no big deal. So his output is a bunch of document symbol, where a document symbol is defined as a symbol kind, range, children of the symbol. Okay, that seems maybe relevant, right? Maybe if we ask for the top level file, he will give us his children, and then we can build the hierarchy that we want. That seems likely. So maybe we'll start here to avoid pulling in Tree Sitter if we don't need it. But yeah, we'll see. We might end up needing it later, but we might as well start with what we have. So this thing says we need to ask the language server for some symbol info. So we call some function, which is just like by call function, they mean throw some JSON over the wire and see what it says. So where does it tell us the name of this function? Request. Text document, document symbol, and he requires these parameters. Okay, so let's go into our LSP thing, and let's just say we have, what is this thing called? Document symbol. So here we have this kind of like Zig way of doing like struct patching, which is kind of fun. So we say like, we have this request message, which is like a base type, and we want to add some fields to it. So we kind of just like define those here. We have the method that we are calling, which is text document symbol. Okay. And we have some params that thing, which is document symbol param. So that looks like this. Now, what goes in these parameters? The parameters extend work done progress and partial result progress. I think these are just, everything in these are optional, so we just won't pass those. And so the only thing that we care about is the text document identifier. And what is this thing? This thing is just a struct with a URI. Okay. So we go URI is this thing. Okay, so this means that this is all we need to do to ask for some stuff. And we should be able to take our LSP abstraction and say, please find me your symbols. So document symbols is going to take in a self, which we have called LSP reference retriever. This might have to be changed, but we will also pass in the path. As an absolute path seems reasonable for now, so we don't have to do any like canonicalizing. We create a URI by just slapping a file : in front. Seems reasonable. And I guess that means that now I can call like send message of Alec with LSP document symbol? Sure. Is that really all this thing has to do? Yeah, okay. Okay. So now what? We have to populate what goes in here. So it's just params. Oopsies, what if I can just do? Here, okay. Params is text document equals URI equals URI. Okay, so that's like theoretically all we have to do. Now we need to send message to the place that we want to go. So self, the LSP server stood in is where we are going, I believe. I think we need this to be a writer as well. Okay, so this should say, hey, language server, please give us the document symbols. And right now we are not really worried about like asynchronous behavior. We're just doing everything in line. So I should just be able to be like, yo, wait for a response to this thing. So can we just start with a partial or like I think that the things that come back are just like response messages. And let's just see if we get something here. So we'll discard this shit. And we leak like crazy here. Just like we kind of just say, look, we're gonna parse some JSON and we don't really want to track where all of that stuff goes. So if you call us, just make sure that you have some other way of tracking what memory has been used. Which is a fine strategy. It's a real strategy. It's real. It's real. So let's say that when we call this thing, we pass in a file. Let's just use that file to do this. So we're going to say like, I think that we can say defer arena reset here. I'm pretty sure nobody has used the arena yet at this point. Yeah, so that's safe. And here we're just going to be like retriever document symbols leaky with our abs file path. Let's just see let's see what we get. And I guess surely this thing is failable because he allocates for sure and he parses stuff, so all that stuff can go wrong. And I guess that's it. I guess here we actually don't want to use we want to use the arena allocator because we expect him to leak. And let's just see what happens. So document symbol is missing ID. So this needs to use self ID allocator next to say, yo, language server, we're a new guy, a new man. And okay, so nothing like went wrong, which is good, which means that this probably did get a response, right? When we waited for the response here. And so now the question is what is in that response? We need to look at that stuff. So we're expecting a document symbol here. So let's just kind of copy paste that shit. Main. Where am I going? I'm going to LSP. So this should actually be like, we need a better name for this. This should be like get document symbol or something. And then here we can like paste this shit and say this is a document symbol. And we'll just kind of start stubbing the types out, I guess. Okay, so the question is which of these things exist and which don't? String, constituate, simple. Symbol kind, I think this doesn't exist yet. I don't know if on the wire symbol kind is a number. I think we can assume that it is. Looks like it fits in a U8. So we'll just kind of see how that feels. Tags is a symbol tag, which is literally just a number. So, oh, this is tags plural? Yeah, this is tags plural. So this is going to be like a bunch of U8s, I guess. It indicates if this tool is, if we're deprecated. So this is just a bool, cool. Range, I think we have defined already, nice. Selection range, we use still range. And then children is our document symbols, that's ourselves. Okay, sure. That's actually not bad at all. So now our response, is it just like a list of document symbols? Result, document symbol. Oh, or symbol information. What the fuck is symbol information? How can we tell the difference? Can we express an or in the like JSON JavaScript world? How do I even know? If he says it's one of these three things, I guess symbol information has a lot of the same things. Oh, I see. So there's going to be some sort of like document symbol common, I think, is probably the thing that we want to do here. And maybe it's deprecated though. Let's double check here. I don't think that this says that it's deprecated. I think it could be either. I think. Yeah, I don't think there's I don't see anything in here that's, oh, deprecated here. Nice. Okay. Okay. All right, we will do it that way. Fine, fuck it. I mean, the language server could respond with that, but we will just ignore it if it does. I like that. So that means that we're expecting a response which is going to be a response message with the results of a lot of document symbols. Which means that here we can say, look, let's wait for a document symbol response and just see what the fuck happens. Okay, so he gets mad because unexpected token. Does he tell me what it is? That'd be kind of nice. It would be nice if he did that. I think that there's a way to extract that info. Maybe let's, before we parse this thing, can we print what we get? Got JSON blob of this guy. Okay. So this is message from JSON start onwards. Let's just see if that behaves any differently. Okay. So this is, we got JSON blob result null. Right. So that indicates an error, I think. I don't really remember. Can we say like enable debug log here? Is that the right argument? If I like spam this with other stuff, yeah, he gets mad. Enable debug log is the right word. It just doesn't really say much here. It just says, hey, we did this thing. So what is he upset about? What is he upset about? It doesn't, I would expect some form of like error code. So when can this thing return null? Let's just double check this thing. So he says, here's our thing, here's the ID, request null. Okay. So I'm assuming that if I typoed like this, it would give me like a proper error. Yeah, here he says that's not a fucking valid method. So that means that the document symbol is in fact being asked for. Now, it's possible that we saw when we were doing find references that the language server did not respond to us unless we opened the file first. So maybe we will do that. Function open file. We have to tell the language server, yo, we are opening this bad boy. Okay. I don't really know how to do that yet. I mean, we have the code somewhere. I just want to, I don't know, pull it out. So it's kind of this stuff. Everything in this block is that thing. So here we will go self open file, and surely we have to pass in that absolute path. Maybe even the URI. Probably the absolute path, and maybe the URI as well, to be honest. So this guy's going to take in the abs path and the URI. Then he says, okay, here you go, bud. He needs an allocator as well. And a writer. Writer is just going to be self process standard in writer like this. Okay, cool. So now we should be able to try doing this over here as well. Technically, we're supposed to close the file as well, but we just don't because we're lazy bitches and ZLS isn't yelling at us. Open file, expected error union type found void. So that means that this thing needs to return an error like this. Okay, let's see if that changed the behavior. Oh, good sign, good sign. That really does look like it changed the behavior. So now we got something, but he's got a missing field. So why? So these things are, Jesus Christ. Okay. Can we I don't know. I want to just like yank some amount of this stuff. Fuck. Test text? Oh, do we do the other way around? Okay. I just want to like extract some reasonable amount of this thing. So can we enu paste and then let's go to this thing and can we just find the alternate bracket of this? Okay. So we have can we do like JQ? Hell yeah, dude. Okay, here we go. Here we go. So we have name, kind, range, selection range, children. Name, kind, range, selection range, children. What did we think we were supposed to get? Name, detail, kind, tags. So he's missing tags. Did we fuck that up? Oh, it's question. Yeah, tags is optional. My bad. Name, name, kind, kind. Details, optional. Deprecated, optional. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Cool. Cool. So now this should work. Hell yeah. Oops. I guess we don't want to do this. Missing field still. Am I high? Did I not save? Name, name. Kind, kind. Range, range. Selection range, children, children. I don't see any missing symbols. Am I stupid? I mean, he's clearly angry. What is the missing field? Maybe some of these don't have them all? Okay, let's do this. Even that has missing fields? Which is pretty interesting. So if I put every single thing as optional, he's angry? Which means that the response message, is he missing like an ID or something? This thing has JSON RPC, ID, result. This thing, result, ID, JSON RPC. Do I need to provide default values so it can succeed? But I don't understand why, like, if... Oh, it could be that in range, maybe? Is range have optional positions? No? And range has both in here anyways. But I guess just for peace of mind, can I do this? And then this? Like, literally just make everything optional. He doesn't like that. Can we do... What if we do this? What if we do that? Okay, you know what? We need to get some proper diagnostics out of this thing. That's kind of the correct answer here, isn't it? Isn't it? So these are the things we're supposed to have. If we go into our parser, I'm pretty sure there's a way to like feed this thing with some diagnostics. So here we should be able to say diagnostics is std.json diagnostics. I think this thing gets default initialized. And then I think that we pass this into our JSON parser. I don't remember how, though. Is it in the parse options? No. Hold on. Zig standard lib. I know it's possible. I know it's possible. Diagnostics. Okay. JSON diagnostics. Enable diagnostics on the scanner. Ah, so we need to make a we need to make std.json reader needs to work on this data. So we say, here is our, I guess we need like JSON IO reader is a std IO fixed buffer stream around message JSON start onwards. Okay. Now we can create a JSON reader out of std JSON reader with an allocator and JSON IO reader, or this reader like this. Okay. Then we can say JSON reader enable diagnostics with diagnostics. Okay. Then we can say parse from token source leaky. And now we pass in our JSON reader here. It's something along those lines. Invalid type given to fixed buffer stream. Probably we put an extra ampersand by mistake. Okay, so now can we say catch error, and can we at least like print the diagnostics here? Diagnostics, I don't know, any? Let's just try to get any fucking info to this thing. Okay. So here we got total bytes before current input 0. That's super cool. That's not very useful at all. What is cursor pointer? Line start number. So this thing, can we get byte offset? Can we do that? $230. So we're 230 bytes in. 230 bytes in. Okay. So let's output this to a file again. And then at least we can see... wrong one. Wrong one. It's this one. Then I go 230 to the right. This is literally the first... He's saying that I'm missing a field at the very first document symbol. Oh, that's so annoying. That's really fucking stupid, man. That's not helping me at all. That's not helpful at all. So let's just make sure that these guys have the right, like, names associated with them. Children, children. Selection range, range. Deprecated is fine. Kind. Name. What is its problem, man? It seems totally fine to me. Okay. What happens if we just say, this thing only has a name field? Fuck you. Oh, let's not... Okay, wait. Okay, this is how we can bisect. So this, we say, what if we add the kind field back in? Totally happy. Range field? Is optional same as empty list? No. But maybe that's a problem? Maybe the diagnostics were wrong here? So it does seem like it's kind of the children thing, right? It's fine again? Oh, I thought that optional meant that it could be like not there. Like, shouldn't this... Maybe I have to write equals null here on all these, which is probably what Two Step was saying like fucking forever ago. I just wasn't paying attention. Ah. Okay. All right, I'll fucking take it. I didn't know that I had to do that. I did not know that. I thought optional would be optional. Seems weird. Yeah, that's what I'm saying, dude. Okay. Okay. So we fucking finally got there. We have a document symbol response. So can we just say for now that this thing will return a list of LSP document symbols for now, which is not public. And we can start exploring this thing. So can we just response and return response result? Value results or something? What does this thing return? This thing returns what I asked for. This thing is like results. Yeah, okay, we're fine. Okay, so if we run that shit. Hello, how goes it? Not bad, how are you? Let's see what symbols, what symbol information we can gather from here. So I think the most important thing here is to see if hierarchy is preserved, right? So here we should be like, if symbol children len is greater than 0, return or std debug print yay, and then immediately returns that we see it. Otherwise, it doesn't happen. Otherwise, there are no children for any of these symbols, and the language server does not support it. He does. Okay, cool. That's really good. That's really good. So that means that the hierarchy does exist here. So can we start like, maybe we just like log this thing? So maybe we say like var indent is equal to 0. Yep, that makes sense. For symbol, we say we want to log an indent however many times we are indented, which means that this has to be a usize, I guess, to make this easier. Then we will say print the name. Symbol name, okay. And then we will say for symbol children. I guess this needs to be like recursive function or something, huh? Let's do this. Const symbol DFS. This is going to take in the symbol list. Nope, not like this. This is a LSP document symbol. Is that the right thing? Yep. And then we will say that each thing will give us a output of some form. I think our output of each of these things is going to be its indent level or like depth, as well as its symbol. Okay. And then here we'll store our index in the list as well as our depth. Okay, which means that now we can just have our next function be like, what do I call this thing? Symbol DFS. So we kind of need to store. It can't just be a singular index. We actually like an index list here is gonna be like an array list of indexes. Is that stupid? I think that's probably reasonable, right? So what we do is we like look at the we say self var symbols is self symbols, right? And for 0 to index list items, for each item, for each index, we say symbols is equal to symbols children, like this. Yes. That seems reasonable, right? Then we just have to check. We have to check if our last symbol is out of range, if we're out of range, right? So we're gonna like defer idx plus equals 1. Dot star, maybe? But if we are out of bounds, no, we don't want to. We only want to do this on the last guy. We only want to do this on the most child index. So I guess here we say like while out of range, we pop. While we're out of range, we go like this. Something like this. I haven't really figured it out. I'm sure that I should know how to do a depth first search at this point, but you know, you have to think about it. So here we say, while the last thing is out of range, we back that fucker up. And I guess we say self index list last. I guess these things only return values, so this is going to be, dude, my brain. My poor little brain. Let me think. It's like I want to check. It's almost like I want to keep like the slice array. It might be easier if I do that. If I keep this, now I don't have to like re-walk the whole tree every time I want to inspect anything. So then I can go like self slices. Last slice is the self slices last, okay. And the last index is self index list get last, okay. Then if we are out of range, we pop both and increment our parent. So we're gonna have like increment last index. Okay. This is gonna be like self index list at self index list items len -1 plus equals 1. So that's simple. That's simple. When here, if we go like out of range, is literally just like index list items, the last index this is the last index. I guess we can go get last here. And the list slice is self slices get last. Okay. Now we say if return idx is greater than or equal to slice length. Okay. So that means now we have while out of range, pop last. Okay. So this is like self index list pop. Yeah, and the slices pop. Okay. And then we increment last index. Here we go. There we go. We're getting somewhere. We're getting somewhere. Then we are no longer out of range. So here we need to check if we've popped everything. Right? Like if our like self slices items len is equal to 0, we're fucking donezo. We're done iterating. We've fucking finished the world. Otherwise, we just look at the thing we're at. And maybe we do this stuff after we like check the value. Yeah. And so this is like something like this. So we're missing something here where we want to do this. Okay, can we just do like function get symbol? Get current symbol. So this will return a document symbol. And here we're just like for self slices items and self index list items. Slice index. Oh, we literally just want the last of each. Right? It's like this. So here we're like get current symbol, increment the index, return ret. Oh yeah, that seems reasonable. And I guess out of range will return false if self slices len is equal to 0. There's no more out of range, so that kind of handles this edge case here. And then now the question is when we initialize this thing, we're going to have, we need like the root, right? The first thing we do needs to return the root document symbol. No, because there is no root. It's a flat list at the top. It's a flat list at the top. Yeah, so I guess when we initialize this thing, we need to pass in an allocator and symbols. Okay. Wait, hold on. This seems reasonable. So we say that these should both be unmanaged. Fuck it. I'll put fix me here. Because we're duplicating the allocator between those two fields, but who fucking gives a fuck, you know? So the slices is initialized with an allocator. And so is the index list. There's probably a way to do this with these allocations, by the way. There's probably a way to like get clever on nesting the DFSs, but this will work fine. This will work fine. Okay. I think that we forgot to push to the list ever, huh? We need to walk the children sometimes, which we haven't done yet. We do have to do that. Slices, append the current symbols, and index list, append 0. We're literally at the first child. Index list append. No, index list should be empty. Because we need to flag that we need to eat. We don't have to just walk the children and get down to the leaves. We have to log every element as we hit it too, right? So the index list has to be starting at 0. If the index list is smaller than the slice list, then we append an index and return the value that we're looking at. Is that true? No, it's not true. Because there's no root node. I keep forgetting that there's not a root. So on the first iteration here, we're going to have we're going to retrieve the first symbol, which is going to be index 0, slice 0. So we're going to get slice 0, index 0. That's the first element. Then we're going to log that with the depth of 1. Maybe depth will be... We need to say that this is the symbol, and the depth, I think, is self slices len -1, right? Because we want, like, if the first thing should have a depth of 0, I think. Okay. So then we say go into index 1. Wrong. This needs to go in if possible. So this needs to be like advanced cursor is self. And here we need to check. So if probably want like the... So if slice at index children len, we don't even have to special case this. We can just unconditionally walk into the child. Right? Yes. So this is going to be like step into child, I guess. And he's going to be like self slices append the current symbol. Current is going to be like an LSP document symbol. He's going to be like, okay, we're going to append current children. And we're going to append a 0 to the index list. And then what will happen is that this guy, if it's 0 length, will immediately say that the index is out of length, pop last, increment the last index. Yes. That feels pretty good, if I do say so myself. That feels pretty fucking good. Okay, so all of this means that we should be able to, like, do... Symbol DFS is a symbol DFS initialized with... Is this supposed to be this hard? Am I just, like, fucking stupid? I feel like this isn't supposed to be this hard, but this is like a lot of code to do a DFS. You just have like, there's a lot of state to keep track of. And I don't know if I'm just like doing it in a fucking stupid way. I feel like it has to be done this way, but I don't know. So now we should just be able to be like print while for 0 to item depth, we print a tab. Okay. Then we print the name. All of this just to print a tree. It was symbol name here. Seems reasonable. Okay. That's a maybe. I guess it doesn't compile. So append is pissed off because he found some const thing at 268. That's true. These guys need to be variable. Yeah, but it will be a pretty tree. Hell yeah. So then when we try to push to these things, there's a failure that can happen. So this needs to be a try, and then this needs to be failable, which means this needs to be a try. No field name len, so this needs to be items len here. Step into child is mad because we need ret here. No. What is being passed in here? Step into child. Current is like this. Okay, while out of range, we need to write self here. Would a recursive function be simpler? But I don't like recursive functions. What is he pissed about? Oh, because this isn't try? That makes sense. I don't like the idea that you can run out of stack space. You know? But maybe that does help. But then when you have our... Ooh. Oh, wait. Hold on. Did that work? Stood allocator app. Friender object. So these are all the imports. Then we have GLFW, the type, has window queue FIFO. Args has... Wait. This is actually like, kind of right. Hold on. Instead run over heap space. Yeah, much better. I want to wait until I hit like gigs and gigs and gigs of memory used instead of like megs and megs and megs of memory used, you know? Okay. Let's look at main. So here we have stood allocator app. That's kind of all these imports here, right? After GFWB, we have functions log error, error callback, all of that stuff, down to scroll callback. So that's all the way down to here. Then we have this GLFW structure. How can the stack real for eyes? Shut up. Window Q FIFO, window Q FIFO, init pinned, D init. I mean, I think this is right. Shockingly. Shockingly, I think this is right. So we get to args. Args has action and iterator. So we probably want to filter out things that aren't that are not functions. Maybe let's log the kind of each of these things. Isn't stack on links like 8 megabytes? Yeah, but it's just like the concept bothers me. And then also the other, like, I mean, less of a meme, right? Less of a meme is that I like iteration to be split out from usage, right? I think that once we have the DFS written, being able to just write this is very nice, right? So there is like some benefit to having these things tracked like this way instead. But there is, yeah, I think there is like increased complexity from that. Okay, let's print the types of these things that we got. So I guess we kind of want like item, symbol. We want to do like kind is item, symbol, kind. But we want this to be like cast back to the enum. So we want like tag name of kind. Are we checking for cycles? No. I don't think there can be cycles if it's like a hierarchy like this. If it was references, there could be cycles, but I don't think there can be cycles in like struct member hierarchy. There shouldn't, right? You can't like type the same. You can't like. I guess if you like wrote like a recursive macro or something in C, then maybe that's like a maybe, but I don't think we need to worry about it. Okay, so we need like kind here, and what were like the list of kinds here? Symbol kind. What could possibly go wrong? Exactly. And it does look like these are just in order. What fucking language is this? By the way, what am I looking at? Okay, so can we just go like Q delete word comma instead of semicolon, And then here we need to set the backing type. So we just set it to like U8. And then we just, I guess we'll use the caps because so we don't have like name collision. Or we could do like this and, you know, just guard the broken names. Sure. Okay, so now we can go like LSP symbol kind with an enum from int, fix me, validate inputs. I guess we can just not fix me. We can just do stood meta enum int to enum with LSP symbol kind. And then does this thing like null? He just errors out, sure. Might add a simple recursive struct to the code base just to check. I don't know how though. I don't know if I can, like, is that possible? Oh, like something that references itself. I see what you're saying. So like object has slice of things that like I don't think you can make like a struct that references itself. I don't think you can have like type. You can do like type aliasing, but like the way that this is walking isn't. It's not walking like the references. It's just walking like exactly what is typed in there. I think, and I just don't think you can have infinite recursion. If you can't type the infinite recursion, you know. Was thinking const foo struct equals child foo. Yes, but I believe if you did that, I mean, we can just check. I believe if you did that, you would just get the name of the field foo or of child, right? If you had like const foo equals struct child foo, I think that you would have what would be walked is like you would have foo would get printed, then you would get child printed, and I think that's it. But I think that you're right. It's probably worth checking. It's pretty easy to check. Right, like I think if we look at foo here, he just says child is a field, right? He doesn't like recurse into the type. He doesn't like resolve the type and keep going, you know? Okay. So now I think, are there any of these things that we don't want? Okay, if we were trying to build a map of all the things in our code base, do we care about child field references? Is that a thing I care about? Because I kind of feel like I want to think about code. Like, let's think about this. What do I want in my graph, right? So if I have like glfw, glfw will have some functions, and he'll also have some fields. Now, someone theoretically could reference this field from somewhere else. That's true and reasonable, right? If I have like main and he types like glfw dot window, that is like a reference. Now, what I'm not confident in is that I care. Right? If we're trying to build like a map of how the code base interacts with itself, I almost kind of feel like I'm okay with having like main references glfw in this case. That's just kind of how I feel. I'm kind of curious what happens if I add an anonymous struct in here. Like if I have like x function x here, what does that look like? Interesting. That's pretty interesting. So this thing gets attributed as a child of the thing. So I was initially thinking that I would only have functions and types in my map, but I guess there's no reason that fields aren't just as interesting. Like, what is the difference between a field and a function? A function is just a field that you can call, right? And so, like, is there, like, there's no reason for me to treat those differently. And if I don't treat them differently, then constants kind of resolve, like, types in Zig, there isn't like a type. There are constants that are like aliases for types. And so, like, trying to disambiguate between this is a type alias versus like any other type of alias, like any other type of constant, is kind of difficult. So I guess it's fine. I don't see any reason why we can't just add fields to our graph. And probably the fields will just be small. It's unlikely that fields are referenced externally that much, and if they are, then we should know about that. Right? If I'm in some function, say we are working on like text box, right? And text box, he has a member of GUI text. So we kind of have like, how would this look? We would have text box. He has a member of GUI text, tb.GUI text. Who we call functions on? Yeah, okay, this is where it gets kind of hairy, right? It's like if I call, so if we have GUI text here, right? And I call self GUI text D in it. I guess if I look for references, no LSP client attached. Let's get in there for a second. Hold on. 1 second. He's thinking. Okay, text box. Right, so if I go into self GUI text D in it here, I guess if I find references on GUI text, it tells me all of the places that this thing is used, and these are all in text box, versus where dinit is used is kind of like in the dinit function. So I guess like in this line is like text box use it like tb GUI text used by tb render, and then GUI text dinit used by tb render. I guess that's kind of reasonable. That's kind of reasonable. Yeah, okay. Sure, fuck it. We'll include fields for now. By the way, I found it simple to depend on. I discovered it's simple to depend on that LSB code gen repo this compiles. Yeah, it might be worth it, huh? What have you done? You have main.zig, he imports LSP, he just pulls in the types, which say, I'm going to use zig LSP code gen, and I assume that this thing just has like, oh, simple. Yeah, nice. Pretty straightforward. Pretty cool. Okay, so I guess we have listed all of our types of functions and fields and constants. We've kind of just list all stuff. It's kind of what we've done. And now I guess we just want to find references for everything. Okay. So that means what? We're going to go into our here, and I guess we are going to build a list of all the symbols. Right? If we eventually want to build some sort of like graph of stuff, right? App is referenced by main. I guess kind of what I'm thinking is like we're gonna have like some array of nodes in the graph, right? So main's one of these, app is another one of these. And I guess we're going to, for each node, list all of the references to that node. Okay. I think that the data storage format will somewhat depend on our expected usage. So I think it's probably worth talking about what our expected usage is. I was kind of initially thinking that I suspect that graph layout is going to be hard, right? Hand wavy, I think maybe impossible, right? To like do a one shot thing. If you just want to say like where should this go, I don't know if there's like a sane answer to that question, right? So I think my first idea here, like as an example, if I have main and I say main references GUI and app, right? That is like a layout. If you just like take GUI and you put it over here, and you take app and put it over here, these are like, this is like an equally valid graph, right? So I don't know if there's like a correct answer that we want. And what I'm thinking is that like as you add more and more stuff here, and the stuff all interacts with each other, I believe that that's going to become like very complex, maybe impossible to lay out sanely. So what I'm thinking is that we could maybe make a small set of rules that are applied kind of in a iterative fashion that will result in something that happens to be sane, right? Like what is like the goal here? You want stuff that is related to be close, right? So I was thinking as a step 1, we could have like um just like GUI here, right? And if GUI uses widget and widget's like way the fuck over here, I think that we should try to pull it, right? We go, oh, hey, I use widget. Widget, come over this way a little bit, right? And then if somebody else also uses widget and they're over here, like maybe like label uses widget, right? Label goes like, yo, widget, come over here. And GUI's like, yo, label, I use label, label, get over here, right? And so I think what I want to do is I kind of want to like lay stuff out a little bit, maybe try to pick like a somewhat sane like initial layout, and then just iteratively nudge stuff towards where I think it belongs. And that allows me to do things like say, this is a bad example, somewhat, because widget is defined in the file GUI, right? And so I don't know if I want to display like a bubble here. Like I might want something that's like one option for things we could do. Fuck. One option for things we could do is we could say like GUI is this, right? And widget is like a thing in GUI, right? And widget has a function in here, right? Like render. But I suspect that I don't actually care that much about this. I suspect that like it might be nice to color things that are related the same color, but kind of let them like make some sort of arbitrary shape, I think. So what I was kind of thinking initially, like for now, as like a step 1, might be that we look at GUI, right? We look at GUI. GUI has like input state. He has pixel bounding box. He has widget as an example, right? GUI, he has bbox, he has widget, and he has input, right? I was kind of thinking that with this like push and pull based model, you could kind of like apply a very strong force to these guys to pull them in towards like the GUI main concept. And as they get farther away, you could kind of like exponentially increase how far they can go. And eventually that would like basically say these things cannot move far away from this like center object. And like if these things are all contributing to like the GUI pull, right? If like somebody over here, main, if he uses all 3 of these, all 3 of these guys are going to move this way and they're going to pull the GUI with him. You know what I mean? Like I'm kind of imagining something along those lines. And so I think that if we go along this model of like, okay, how would this actively get applied every frame or every iteration? Every iteration, you would loop over every object, and you would say who references me. Okay, I'll like who wants to pull me. Okay, you want to pull me, you want to pull me, you want to pull me. Let me add up those pull vectors and then like make that movement. Right? Which means that if we only stored references to a thing, if we had an array of refs, like refs per node, that would work fine, right? It means that we could like rip the array in one, like in n steps. There's no like n squared here. We don't have to compare everything with everything else. We literally just say like, okay, who wants to pull me? I'll walk towards you. Now, the only problem here is imagine that we initialized every single thing in one point. Everything is right here. If everything is only pulling, that's a problem. We might need to like push things away from each other if they're not connected as well, right? That's a thing that we're gonna have to like think about. And my thought there was we could check. We could say that things like everybody in the world wants to be some distance apart, and we could like maybe break the world into cells, right? And say like if there is more than one thing in a cell, literally just push everything in a random direction, right? So if there's like if we have like things spread out like this, everybody's happy, everyone's happy. But if we have like a cell here that has like 10 things in it, we'll just kind of like shoot them all out, like just kind of like get the fuck out of here, right? Which should create some sort of like initial randomness so that pull only behavior would work, right? Otherwise, we would need to check our proximity to every other node in the graph, which would be n squared, which would be kind of shit. So all of that to say, I think one array, if we just store everything in like one 2D array, like of references, so we have like each node has like a variable length list of people who are connected to him or who reference him. I think that's good enough. I think. We will see. We will see. So, all of that to say, if we want to write down this stuff, I think that we can say db. Calling it a db is kind of funny. It's not really a db, but like we'll call it a db. And here we'll say nodes. And here, I guess we will store document symbol. Now, I forgot that we want to store parents. So this will be node ID, I guess. And we also want to store referenced by, right? Parent. So this is kind of like this. So something like this. Maybe we do value size like this. That doesn't seem crazy. It doesn't seem crazy. So we just rip the whole list of shit. For each thing, we write down it's his direct parent. Maybe we have to write down, if we do that kind of like exponential pull thing, each parent will pull his children. They don't need to be pulled by their grandparent as well, because the grandparent will pull the child will pull his child. And so that's all fine. So yeah, we just need to store one parent. Maybe he's an optional node ID here. Most things will have a parent. And then do we want to store the whole symbol here, or do we just want to store like its name? Maybe we want to store some sort of like, maybe we want to decouple ourselves from the document symbol. So maybe we say node is a struct, and the node just for now has like name and kind. I don't know. Maybe. Seems reasonable. So I guess we have to build, like, these are nodes. So we will DFS this thing, write down the nodes, and as we walk, we will just ask for our parent. So that means that our DFS needs to store the parent here. And maybe what happens here is he stores like the node ID here. maybe he'll be like iter. Hold on, I'm thinking for a second. We might need a unique name because if we modify this thing in the future or we try to rescan and the file is changed, things might have moved around, right? We might have lost things might have like switched order, which means that we need some sort of like hierarchical name for this thing, a unique identifier for this thing. So it could be that in the database, our nodes have a name of main dot glfw dot like whatever the fuck, right? Like I don't remember what our list looks like. Main dot label text buff dot buff or something, right? And is this how we want to store stuff? Because he needs some unique identifier. Another option is that we store like, well, we have main is a node. Main would be like node 0. Label text buff would be node 1 and buff would be node 2. So it could be that these things are uniquely identifiable by their name and their parent list. Could be. But I suspect this will be easier for now. I'm kind of okay with hard coding like the full path to the object, and then we can just strip off the back parts if we don't care about them later. I think that will make our lives easier. Okay, let's do it that way. Which means that this guy he'll just kind of output whatever he's outputting, and whoever's using the symbol DFS now, let's have them create a kind of like more advanced name, right? So we can be like name stack here is a stood array list of names, right? And as we walk this thing, we append the name to the stack. So we say like if item depth is less than name stack items len. Fuck. This means that we need to indicate when we leave a section of the depth DFS as well, right? If we're going like through the tree of like main, I guess we're kind of indicating that already. We do indicate that because we have if the depth is less than my current depth, then we have moved. I think that's true because we always touch the nodes at each level going down the graph, right? But the iteration is like if we have a tree like this, boom, 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 we go 1, 2, 3, 4, 5, 6, 7, right? And so here we know that when our depth was 3, and if the depth comes back to 2 or back to 1, we know to pop elements of the name. So if the depth is less than our current name stack length, we go name stack resize to item depth -1. No, item depth actually, because this is item depth 0. So if we are like at item depth 1, we want to resize so that this is the only thing in the name stack, and then we'll push this directly after. So here, then we just go like name stack append item name. Okay. And then we should be able to like print out for name stack items. We should be able to print out the like component. We have to handle the first element differently. So we'll do it like this. So on each of the 1 to n elements, we prefix with a dot. Name stack items I, like this. And on the first element, if name stack items len is greater than 1, I guess we have to handle this case differently, huh? It has to be kind of like this. Because otherwise this for loop will get mad that the like start index is lower than the end index. It has to go in order, unfortunately. I guess it's kind of like this. So we guarantee have a 0 here. Yeah. Yeah. We print the first item, we add a dot, we put the second item, and then at the end of this, we put his field name. Yeah. I think that's fine. Let's see what happens if we do that. Fuck. Seems like it's working. Seems like it's working, right? So we have like foo child x, glfw window, args action, load, args action new brushes. That's feeling pretty good. Okay, so now we should be able to push each of these things into the node list. And as we push them, I guess in the same way that we have the name stack here, we can actually call this like parent stack. In which case, do we really need to store this stuff ourselves? We could like extract this from our like depth first search walker, right? He has all of this stuff kind of right here already. So maybe we could do it here where we have like like this output could hold all the parents. We could do that. Do we want to do that? Have you ever heard about Clojure? If so, what do you think about it? I've heard the name. I don't really know much about it. I guess we can't really do this because we don't have that array sitting around. We could make it, but I don't know if like we really want that. Yeah, fuck it. We'll track it over here. It's fine. We'll track it externally. I don't mind. So parent stack, we'll call it, and we'll say that we have some sort of like what goes in this thing. We want to hold onto his node ID because we're going to be like using this depth first search walk to push into the database, right? So we're going to say that we want like the parent ID is a node ID, which comes actually from db.node ID like this. And then we want the parent name. And really the parent name will be kind of stored in the DB. So really let's just say that the parent stack is a bunch of DB node IDs like this. Okay, so for each item that we walk from this thing, we're going to push the item into the node stack. Or so we're going to say like db is a db. Probably this thing can just be like default initialized. These are going to be like stood array list unmanaged probably. Okay. Sure. Something like this. Then all of these things can be like default initialized like this. And then we can start building this shit up. So, what happens here? We got an item. Put that shit in the DB. Add node of item. Surely, like, there has to be some sort of add node thing in here. So here we're going to be like, give me a name and a kind. I think I'm okay to use LSP symbol kind for now. I'm not like super happy with that. I would like to decouple this thing from the LSP a little bit, but for now it's fine. And parent is a node ID. Then here we can go like self nodes append. We probably want to duplicate the name. We probably want to like store this shit internally. So Alec dupe name. Okay. Probably we give up if we gotta clean our shit up if we fail. So he has name equals name duped. Okay, and then kind is equal to kind, and the parent. I guess there's no reason why all of this stuff can't just live directly in the node, huh? I don't really know why we did it this way. Referenced by. Yeah, that feels nicer. That definitely feels nicer. Okay, so then we have parent equals parent. And name updid typo. I think it says duped everywhere. I think oh, updid over here. Dude, that's a real big typo. And then here I think we'll just put reference by and say this can be default initialized. When we push these things to the node list, they can't have any references because this thing didn't exist yet. So then we can just go like, let me add this node. We use our allocator. We use our name. We use the kind. And here we say that our parent is parent stack items, parent stack get last. Yeah. Okay. Seems reasonable so far. Yeah. Okay. And then now we can use the parent stack here. And instead of using the items here, we say like db nodes at this thing name or something. I think it's like this. DB nodes items at this. Okay. And we actually need to, our name should actually just be like, if we're storing that like dot name, that like a.b.c.d, if we're storing that in the database, then we don't have to do this whole walking every time. We just have to be like, we want to go like, okay, my name is my, no, we say like name start is equal to, I don't know, man. This can fail. Because this could be, we could be at the root here. If we have a parent, we do one thing. Otherwise, our name start is like literally nothing. Okay. Yes. This is making sense. DB nodes items. ID probably value. I think it's something like this because our parent is a DB like node ID. So instead of doing it this way, can we do? We need to wrap this like function get node with self of DB and node ID is a node ID. Returns a node, and he just returns self nodes items ID value. I do it this way because it's kind of nicer. If I want to like change the storage format, one, like these node IDs make sure they don't accidentally use the wrong indexes in the wrong spots, and two, it makes it that we can change the implementation of this without really worrying about it, which is kind of nice. Okay. Sure. So seems reasonable so far. Seems reasonable. Okay, so then we have like new name is going to be stood format buff print of this dot this of the name start and item name like this. Okay. Sure, I don't know, man. So then when we push this thing, we use the new name. And then we don't have to do any of this shit. We just print the new name here. Okay, let's see what that does. Look. Parent stack append. True, I don't know why it's like this. So here we need to, when we append to our DB, I guess we do this. I guess. Yeah, that seems reasonable. Let's see what that does. New name is mad because he's right try here. Sure. And then nodes append needs allocator here because it's unmanaged. Okay, then append node ID is mad probably because of a try missing. Okay. All right, let's see what that does. There's an extra dot at the beginning. True, because this needs to check. So here we need to do like sep is equal to if name start len is equal to 0, it's nothing, else it's dot. There we go. Simple. Simple. Okay, so now we have UI action dot that dot. Yeah, seems like that's working, but now all of this stuff is like living in our database, which is huge for us. So now we need to we need to ask the language server for references for each thing in the database, right? So how the fuck do we do that? I guess that means that we need to write down the location of this symbol, right? So I'm kind of down. I just realized that we can get out of the kind thing if we just store instead of storing the kind like this, we can just do like tag name right here, which is kind of fun. Right, we can just do this, and that kind of solves the problem. Okay, and then we can also store the location, and we'll just say, okay, item lock is a struct that has a row, like line, and a call. And we'll just put a comment here that says 0 indexed, just in case that's like ever not clear. And then here we will just write down the item location. Okay. And then does it start making sense to actually just like fucking huck the node in here? Like maybe instead of all of this, we're just like literally just give me a node, please. Yeah, fuck it. And then we still need to dupe the name, that's true. So can we do clone? It's probably the way. Probably the way. So we say name is equal to dupe u8. We need to do like alloc dupe u8 self dot name. Okay. For alloc free name. Oh, I don't want to do this either. Okay, change my mind. Change my mind. We don't take in a node here. We take in something that looks a lot. I guess we'll just fucking pass in the parameters. Fuck it. Fuck it. I don't know, man. I don't know. This doesn't need to say item in it. We don't need to prefix fields of item with item. That's fucking stupid. Okay, so that means that here we need to like get that location. So line is probably like item dot symbol dot range dot start line, and call is their character. Okay, and then we pass in the lock here, chillin', which means that now we should be able to rip our node database, and we should be able to find out who references them. And actually, we actually want to store the whole range here, actually. Because if we want to figure out who references us, the references that come out, I believe, are in like line. They're just kind of like a line and a column. And if we want something more interesting than that, we're gonna have to like look up in our database the line ranges for a given type and attribute that correctly. So where he's a result location, yeah. Where a location is just like a range. Yeah. So we actually want range. And we want pubconst range as a struct of start and end. Okay. Okay, it's coming together. It's coming together. Okay. That means down here, when we like construct this thing, this is the start and the end. And then our range is a range of start equals start, end equals end. Okay. So we should just be able to like iterate these things. So I'm not really confident this thing is going to stay like an array list like this, but fuck it. For now, we will just rip it that way. We'll put a fix me on it. Do not access nodes directly. We have our DB is actually up here somewhere. I don't know why there's a scope here. This will kind of do it like this. And we'll say for DB nodes, node. How are we going to do this? We actually need node IDs, which I guess we're going to have to make so. It's fine. So we have like some sort of ID iterator. This thing literally just pumps out. He literally just pumps out sequential IDs. But we don't know that externally. We don't know that. So this thing is going to return a node ID like this. He's going to take in self of an ID iter. He's going to be like, if self IDX is greater than or equal to self max, return null. Otherwise, defer self IDX plus equals 1 and return self IDX. Wow. Okay. Self nodes items len. Okay. So now we go node iterator is db ID iterator. This gives me while we go next, we have some ID. We say db get node at ID. And we do something with that thing. I don't know what yet. I don't know what, but we have to do something. Presumably, we say, find me some references for this thing. At the node line node range start line and the node range start call. Okay. And then I guess at each iteration here, we reset the fucking arena. Seems reasonable. Because this is leaky, and I guess we're going to say references to this. Seems reasonable, and then each reference is just going to be indented, I guess. Sure. Okay. Okay. This seems seeming reasonable. Okay. What happens there? Fuck. Item lock. 449. These are just called lock now. True. True. And then self IDX is pissed off about what? Oh, yeah. We do need to turn these things into node IDs. True. Okay, so he's pissed off about integer overflow at 22077. Actually, this has been there for a while probably, and we just haven't been looking. So, if self IDX list items len is 0, return. Nothing to do. Okay. So now we're getting leakies like fucking crazy. So instead of fixing them, I'm just going to comment out the GPA DINIT. If we don't see the leaks, they don't exist. Perfect fix for us. And so now he's saying there's no references, which means that we have a problem. Maybe no references is okay. Maybe no references is okay. So instead of doing a failure here, can we do like maybe we just do a continue here. Let's just see if that kind of like fixes us up a little bit. Okay. So there's a lot of other shit printing. Can we just kind of comment all that out? Just for now. Fuck. Fuck. There's like time logging I don't want. Can we disable the fucking child language server logs as well? It's fucking annoying. Where do we like stood error behavior? Like shut the fuck up. You know? Shut the fuck up. That's what I would say. Okay. It's not crazy. I mean, this is really slow, but let's see. Okay, let's look at like the references to create path and see if we agree. Right? There are 2 references to create path. It might not be getting one of them. Right? It's getting one at 3074. That's not helpful. These are not helpful at all. That's useless. Let's see about like parse state fonts. So this should be 191. This is literally just writing the definition. So I thought that our find references was supposed to ignore definition. But I guess it's not. Now, what's concerning to me here is that if I'm going to find references on args parse, he thinks there are no references to that, which is not good at all either. That seems pretty bad. Can we write down where we think this thing is? Because I'm not convinced this is doing the right thing. So this is references 2. Can we just write down where we think this thing is? Can we just like, whoa. Is this debug build? Yeah, but I think the problem is like the speed of the language server more than anything. Oh, this is changing, huh? Okay, so we think parse is at 198.4. So this is 0, 1, 2, 3, 4, 5. Ah! Aha! Fuck me. That's not good. That's not good at all. So the range of this is probably... It's probably like the full fucking range of the function. Which means that we don't have the fucking label name, which might be a fucking mega problem. We're in the wrong fucking folder. That's not good. So we might need some tree sitter help in order to find the actual identifier. So I would like to see this thing has a range of like here to here. So the start is here, node, range, and line, node, range, and call, right? Like, I just want to look at like args parse or something because we were already looking at that one. Okay, keep going, keep going. Okay. Yeah, that's not good. So he is including the token function. He is giving us actually what we asked for. This is actually what we want to some extent. We want the entire range of the function so that we can attribute other references to that thing. But if we want to find references to this function, we need to position the cursor over the name of the fucking function, which we can't do because we don't know where it is. Right? We can't just use the start thing. We could if we want to like cheat for now, we can just write like +3 here, because we know that functions have a fn space at the beginning, but we need something to do a little better than that. So now if we get into function parse, I assume that we'll see. Seems too slow. Are we sleeping? No, it's ZLS is not fast. I'm pretty sure. I'll have to double check, but I think that that's what it is. Last time when I looked, it was like ZLS takes like 600 milliseconds to respond to something. Yeah, okay, so now function parse is correctly resolving that it has a like a thing. Okay, so that's interesting. But I mean, theoretically now, if this works, we can be like node, probably get node here should have get node pointer. That takes in this thing by pointer here as well. Then we can do like get node pointer, and we could update this thing now. We could say like node dot reference by, and we can append with an allocator of, you know, all this stuff, right? We can do that now. But before we do this, we actually have to say, this gives us a reference location, right? So we actually need to go over the whole database. So we actually need to do node iterator 2 is this for while node iterator 2 next, we have like potential ref, right? And then we go like if potential ref value, nope, if node db get node potential reference, I guess it's an ID, potential ref is equal to this, if potential ref range contains, and we say that this is the location, we could do something like this. Then we say, okay, this is referenced by that, right? This is how we would like build like the entire map. But I worry that like we need to solve this. So the fact that we need to solve the fact that the start of the range does not give us somewhere where we can find references on. It's a little confusing. Oh, fuck me though. Fuck me. There is a find references by name. I know this exists. Fuck. LSP find references by name. I'm pretty sure. Telescope, LSP references, maybe not. I could have sworn there's a way for me to type in a name that I'm looking for. But maybe not. And even then we would have like name collisions and that wouldn't work. Okay. Okay, so I'm gonna have to think about it. It's likely that we pull in tree sitter here as a way for us to parse the abstract syntax tree. We probably still want to, we might like completely replace this way of like finding like ranges of stuff with tree sitter, because I think it's kind of built for that. Which means that this is kind of a waste, but I think you have to explore. You have to explore to find out, right? So, if we got that, then we would still use language server to find references. We have like a database now that we know how to build, which is pretty sick. Once we have this, we can start working on like presentation. So I think we call it there for today. It's 4 o'clock. I got somewhere to be tonight, so I can't really extend much longer. I think it's a natural good place to call it. Thank you for watching, guys. If you like what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time right now. So you would, if you are watching live, expect to see us online between 3.5 hours ago and now. If you're watching live and you're like, I want to see the follow-up to this, but I won't be online every day at that time because I've got a life and things to do, there's a YouTube link in the Twitch description. things are organized into playlists. We're working on building a map of my code. There's other stuff back here if you want to check it out. You might say these videos are 2 hours long, but you said a 3.5 hour time block. What's up with that? That is because the 12:32 segment is kind of more like chill, less focused. There's a lot, like, in order to like post a YouTube video, I need to have some sort of like story to go with it, right? What are we working on? Like start to end, here's a feature, right? But there's a lot of stuff that isn't feature development, and there's a lot of stuff that like maybe I just want to work on stuff without like a plan. So that's the kind of stuff that ends up in happy hour. Today we were working on combo box support in our GUI framework. So pretty exciting stuff. Does it work? Does it work? Maybe. Hold on. We can show it. We can show what we made today. That'd be cool. Look at this. Wrong command. I've been working. Here we go. Look at this shit. Look at this beautiful combo box. We click mask mall. Boom. Boom. Look at that. And if I start spamming this combo box now. Boom. It's got a scroll bar. Wow. That's what we're working on today. So if you want to see that type of shit, you have to subscribe on Patreon or join on YouTube or subscribe on Twitch, and those VODs will be available to you in the appropriate places. Otherwise, thank you for watching, guys. That's all the plugging we got to do. We are going to raid on Twitch and YouTube. Peace out.